Under the vast expanse of the celestial sphere, a massive scarlet star among the most luminous and easily distinguishable stellar bodies asserts its dominance along the horizon. Situated far beyond our full understanding, this immense cosmic entity possesses the capability of releasing an energy magnitude that could rival the combined radiance of an innumerable array of stars. This astronomical giant, possibly on the verge of an apocalyptic event, may soon unleash a burst of such magnitude that it could outshine 1 billion suns. The real question is, are we prepared for the aftermath such an event could bring? This colossal red star, often referred to as Goliath, resides relatively close to Earth and has emerged as a subject of significant fascination and debate within both the scientific community and the broader public. Recently, this star underwent a considerable transformation, prompting growing concerns among researchers and fueling intense discussions regarding its future trajectory. The most alarming possibility is that this alteration might signal the early stages of a supernova, an explosive stellar phenomenon marking the final phase in a star's life cycle. If Alpha Orionis, the scientific name for this star, were to exhaust its nuclear fuel, it might collapse under its own gravitational pull, triggering a catastrophic explosion. The very thought of such an event sparks anxiety not just among scientists but also for those of us inhabiting Earth, as the potential consequences could be extraordinary. Alpha Orionis, easily recognized by its deep crimson hue, holds the title of being the largest and most radiant star in the Orion constellation. With the aid of advanced tools such as NASA's Hubble Space Telescope, astronomers have closely observed its behavior, particularly in 2019, when it experienced a dramatic loss of mass, a phenomenon that is considered rare for stars of this type, raising alarms across the scientific community. While our Sun frequently undergoes coronal mass ejections, the unusual event witnessed in Alpha Orionis has sparked a re-evaluation of what occurs during the final stages of a massive star's life. Scientists are currently divided over the precise distance of Alpha Orionis from Earth. Estimates vary, with some placing it as far as 1,200 light-years away, while others suggest it might be as close as 724 light-years. The difficulty in accurately determining the position of stars like Alpha Orionis lies in the immense distances involved and the peculiar nature of red giants. Despite uncertainties regarding its precise location, Alpha Orionis continues to captivate observers as one of the most awe-inspiring objects in the night sky, shining several times brighter than our Sun. However, this radiant glow comes at a significant cost. Alpha Orionis is consuming its nuclear fuel at a rapid pace, which accelerates its journey toward the inevitable end of its life cycle. Once it exhausts its fuel supply, the star will likely collapse, possibly forming either a neutron star or, in a more catastrophic scenario, a black hole, depending on the manner in which the explosion unfolds. This leads to a pressing question. Could Alpha Orionis pose a threat to Earth? Should a supernova occur within a few light-years of our planet, the ramifications would be devastating. A supernova can release an unimaginable amount of energy, potentially outshining entire galaxies, which presents the possibility of far-reaching consequences. Even if Alpha Orionis lies at a considerable distance from our planet, historically, the last supernova event recorded within our galaxy took place in the year 1604, and since then, humanity has not witnessed a similar occurrence on a local scale. However, a significant supernova erupted in 1987 in the Large Magellanic Cloud, located a staggering 169,000 light-years away. Although this explosion had notable consequences for its immediate environment, it posed no direct threat to Earth. Nonetheless, these rare events serve as potent reminders of the immense scale of supernova explosions and the dangers they may present. A supernova, particularly one occurring close to Earth, could create what has been termed a danger zone around the stellar explosion. The risks to life on Earth, however, should be viewed in the broader context of cosmic events. While supernovae are infrequent occurrences, gamma-ray bursts, GRBs, represent an even more potent threat. These bursts are capable of annihilating entire planetary biospheres and flooding them with deadly radiation. For instance, GRBs have the potential to destroy a planet's ozone layer, leaving it exposed to harmful ultraviolet radiation from its sun, effects that could persist long after the burst itself has subsided. This looming threat of gamma-ray bursts has become a focus of recent research, shedding new light on the potential hazards associated with stellar explosions that culminate in such dramatic and destructive events. When massive stars explode as supernovae, their brightness can surpass that of entire galaxies. This intensity raises an important question. What would happen if Alpha Orionis were to undergo a similar transformation? Should it explode as a supernova, it could become the second brightest object in the sky, second only to the Sun in terms of visibility. Even at a considerable distance, the energy released in such an explosion might be so intense that it could be visible even during daylight hours. This blinding spectacle would cast shadows in the middle of the day, offering a striking yet unnerving experience for those witnessing it. While the visible light emitted by a supernova would undoubtedly be a striking sight, the real threat lies in the high-energy radiation accompanying such an explosion. This radiation, typically in the form of X-rays and gamma rays, would have far-reaching consequences. One of the most pressing concerns is its potential to deplete Earth's protective ozone layer. Without the ozone layer, life on Earth would be exposed to harmful levels of ultraviolet radiation, potentially leading to extinction events. The dangers posed by a supernova do not cease immediately after the explosion. The remnants of the explosion, including shock waves traveling at nearly the speed of light, would continue to pose threats as they spread throughout the solar system. These shock waves could further damage the ozone layer, subjecting Earth to an even greater risk of harmful radiation, which would only heighten the dangers over time. Moreover, the long-term consequences of a supernova's energy release could linger for centuries, leaving lasting damage to the planet. Interestingly, some studies suggest that Earth may have already been affected by the aftermath of a supernova in the past. Elevated levels of iron-60, a radioactive isotope produced in supernova explosions, have been detected in deep-sea sediments and lunar soil, indicating that Earth has likely encountered the fallout from such an event within its geological history, possibly within the last few million years. At present, there are no known supernova candidates near Earth that pose an immediate threat. However, ongoing research is continuously uncovering new potential threats, particularly from supernovae capable of emitting long-range lethal radiation. These supernovae occur when a star nearing the end of its life is surrounded by a massive disk of material, and the shock waves from the explosion interact with this material, creating intense X-ray radiation that can travel vast distances through space. This radiation has the potential to affect planets within a 150 light-year radius. Thankfully, no such candidates have been identified in our vicinity, but this research has offered fresh insights into the concept of the habitable zone, the region of space where life-supporting conditions may exist. It appears that this zone may be more restricted than previously thought, with outer regions of galaxies lacking sufficient star formation activity to support the development of rocky planets. On the other hand, the inner regions, where stars are born and die more rapidly, may pose risks due to the frequent occurrence of supernovae. As scientists continue to examine the remnants of supernovae, they are discovering that these cosmic remains can give rise to new stars, forming stellar nurseries from the expelled material. This process highlights the interconnected nature of the universe, where the death of one star often leads to the birth of another. Furthermore, supernovae have proven to be invaluable tools for measuring cosmic distances. Type Ia supernovae, in particular, are used as standard candles, allowing astronomers to gauge distances between galaxies with remarkable precision. This technique has refined our understanding of the vastness of the universe and provided vital information about dark energy and the accelerating expansion of the cosmos. The remnants of supernovae, which consist of the material ejected during the explosion, play a crucial role in the formation of new stars. These remnants serve as stellar nurseries, where fresh stars are born from the gas and dust left behind. This cyclical process, where the death of a massive star leads to the creation of future generations of stars, drives the evolution of galaxies and contributes to the ever-changing structure of the universe. As astronomers continue to investigate supernova remnants, they are finding that new stars can emerge from the gas and dust in these regions even years after the initial explosion. Supernova remnants, with their complex compositions, are also one of the universe's primary sources of heavy elements. Elements like iron, gold, silver, and uranium are formed in the extreme conditions of a supernova explosion, and they are scattered into the interstellar medium, enriching the matter that will eventually form new stars, planets, and even life itself. Without these heavy elements, the solar system and, indeed, our existence would not be possible. Supernovae, therefore, are not merely destructive events. They also play a vital role in the creation of the very elements that make up the stars and planets we observe today. Furthermore, the study of supernovae has deepened our understanding of the universe's expansion. By observing the brightness of type Ia supernovae caused by the explosion of a white dwarf in a binary system, astronomers can measure cosmic distances with extraordinary accuracy. These standard candles have revolutionized our ability to map the universe, providing crucial information about dark energy and the accelerating expansion of space. Despite the significant advances in our ability to measure cosmic distances, the potential dangers posed by supernovae cannot be overlooked. Although the likelihood of a nearby supernova affecting Earth remains low, the long-term consequences of such an explosion could be profound. As mentioned earlier, supernovae emit intense radiation that could disrupt the solar system's environment. This radiation could interact with Earth's atmosphere, depleting the ozone layer and exposing life to harmful ultraviolet radiation from the sun. Without the ozone layer, survival on Earth could become increasingly difficult, if not impossible. Additionally, the shock waves from a nearby supernova could disrupt the structure of the solar system. These waves would compress the interstellar medium, potentially triggering the formation of new stars or altering the orbits of objects within the solar system. In the worst-case scenario, a nearby supernova could disturb the delicate balance of the solar system, leading to catastrophic changes in planetary orbits and possibly even threatening Earth's existence. The study of supernovae and their remnants also raises fascinating questions about the future of the universe. As stars die and supernovae occur, their remnants can eventually form black holes or neutron stars, some of the most enigmatic and extreme objects in the cosmos. Black holes, in particular, are regions of space where gravity is so intense that not even light can escape. These objects are believed to be the final stage for the most massive stars, and their formation is one of the most intriguing phenomena in modern astrophysics. Despite their destructive nature, supernovae are integral to the ongoing evolution of the universe. The materials they release into space serve as the building blocks for the formation of new stars and planetary systems. As new generations of stars are born, the cycle of stellar life and death continues, driving the evolution of galaxies and contributing to the universe's ever-expanding nature. In conclusion, while the potential threat of a supernova explosion remains a distant concern for Earth, the study of these events is essential for advancing our understanding of the universe. Supernovae not only provide valuable insights into the life cycles of stars, but they also offer crucial information about the chemical composition of the cosmos and the ways in which galaxies evolve over time. As we continue to explore the vast reaches of space, our understanding of these dramatic cosmic occurrences will deepen, offering a clearer and more comprehensive view of the universe's past, present, and future. As we move forward in our exploration of the universe, it is clear that studying these immense cosmic phenomena, like supernovae, will continue to reveal new layers of understanding about the universe and its intricate mechanisms. Each step in this research brings us closer to grasping the true scope of how stars live, die, and contribute to the dynamic, ever-evolving universe around us. Supernovae and their aftermaths, such as neutron stars and black holes, represent some of the most fascinating and mysterious aspects of astrophysics. These phenomena raise profound questions about the ultimate fate of stars and their role in the larger cosmic framework. The processes that lead to a supernova explosion involve extremely complex nuclear physics, and yet the resulting impacts stretch across vast distances, influencing the evolution of entire galaxies, influencing the birth of new stars, and enriching the cosmos with essential heavy elements. Understanding how these events unfold and the conditions that trigger such explosive events help scientists piece together the puzzle of stellar evolution. In addition to the critical role they play in star formation and the creation of elements, supernovae serve as a critical tool for measuring cosmic distances. By analyzing the light from these dramatic stellar explosions, astronomers can create more accurate maps of our universe, tracing the expansion of space and the distribution of galaxies across vast distances. These measurements are essential in determining the age, scale, and structure of the universe, and they have led to groundbreaking discoveries regarding the mysterious force known as dark energy, which appears to be accelerating the expansion of the cosmos. This precise ability to measure distances using supernovae has had ripple effects throughout astrophysics. By providing more detailed and reliable methods for gauging distances across the universe, we have gained a deeper understanding of the rate at which the universe is expanding and how galaxies are evolving. The presence of dark energy, first inferred through observations of distant supernovae, has reshaped our understanding of the universe's future, suggesting that the cosmos is not only expanding but doing so at an accelerating rate. Yet despite the incredible knowledge gained from these supernova studies, the potential risks from a nearby supernova explosion remain a fundamental concern. While such an event is unlikely in the immediate future, the possibility, however remote, demands our attention. The destructive effects that accompany supernovae, particularly the radiation and shock waves they generate, can have significant impacts on nearby planets. If Earth were to fall within the range of such an event, the consequences would likely be catastrophic. From the destruction of the ozone layer to the disruption of the solar system's delicate balance. Understanding these risks forces scientists to think deeply about how life on Earth could be affected by cosmic events. If the ozone layer were to be depleted by radiation from a supernova, Earth's atmosphere would no longer shield life from harmful solar radiation. The planet could be bombarded by lethal ultraviolet rays, leading to widespread environmental and biological damage. This presents an existential threat to life as we know it, making it essential for researchers to continue their studies into the effects of supernovae and other cosmic hazards. Interestingly, some scientists propose that the early Earth may have experienced similar catastrophic events in the past. Evidence from isotopes found in ancient geological deposits suggests that Earth has encountered the remnants of past supernovae. This suggests that supernova explosions are not just theoretical risks, but events that may have had a tangible impact on the history of our planet. Whether such past supernovae played a role in shaping life on Earth or caused mass extinctions is still a subject of debate. But the possibility that these cosmic explosions have influenced our planet's history adds another layer of intrigue to the study of supernovae. As research into supernovae and their aftermath continues to evolve, astronomers are also investigating the potential effects of gamma-ray bursts, GRBs, which, while rarer, are even more powerful and destructive than supernovae. Gamma-ray bursts can release an immense amount of energy in a fraction of a second, far surpassing the output of a typical supernova. They have the potential to sterilize planets by obliterating their atmospheres, including their ozone layers. This makes the study of gamma-ray bursts an important area of research, as their extreme nature presents a danger to planets situated within their path.